In this video, I want to have a look at intercepts and signs of graphs. So we know that when the graph of a function is above the x-axis, the function is positive, and when it's below the x-axis, it's negative. That also means that if it's exactly on the x-axis, then it's equal to 0. And that means that we're able to solve inequalities using the graph of a function. All right, so let's have a look at this example. So we want to find two things. We want to find when our function is less than 0, so that's when it's negative, and we want to find when our function is greater than or equal to 0, so that's when it's positive. So this first one, that's going to be whenever our function, our graph, is below the x-axis. So that happens in two different places. It happens over here, and then it happens in this section as well. So first off, it's going to be when x is less than 1. So because it never curves back up, any value of x that we sub in there that's less than 1 is going to give us a negative value. So we've got x is less than 1. But we also have this chunk in here where x is between 4 and 5. So we've got x is greater than 4 and less than 5. Right. And then if we've got we want the function is greater than or equal to 0. So that would be this whole section here and this bit as well. So again, there's going to be two inequalities that we need to write down. So it's greater than or equal to 0 between 1 and 4. So x is greater than or equal to 1 and less than or equal to 4. And it's also positive when x is greater than or equal to 5. The other thing that's going to help us solve inequalities is this definition. So a function is continuous at a point if its graph can be drawn through that point without lifting your pen off the paper. So an example of a graph that's not continuous would be a hyperbola, because you've got one section, if you've got your axes, you've got one section down here, and then you have to lift your pen off to draw the other section. So it's discontinuous. The only time a continuous function can change from being below the axis to above the axis is when it crosses the x-axis, or when it has a 0 or an x-intercept. So the only way, if it's continuous, that we can get from down here to up here is if somehow we cross that axis. So we're going to use that knowledge to solve this example. So we want to sketch the function y equals x minus 4, x plus 3 squared. So the first thing we want to do is find those x-intercepts. So we're going to set y equals 0. So we'll have 0 is equal to x minus 4, x plus 3 squared. So we know that either this has to equal 0 or this has to equal 0. So that'll give us x-intercepts of x equals 4 or x equals minus 3. So if we draw up our axes, our x and our y, we know that our graph is going to pass through 4 and minus 3. So we know it's going to go through those points, but we don't know how. We don't know how it's going to go through there, where it's going to be positive or where it's going to be negative. So we need to figure that out. And we're going to do that. We're going to draw up a table of values. So we're going to have x and y. We're going to put in a couple of different things. We're going to put in our two intercepts, and then we're going to test a point either side of both of them. So we'll have minus 3 and we'll have 4. We want to test a point on this side of 4, so let's just go 5. We want to test a point that's in between minus 3 and 4, and you can pick any point in there, but 0 is usually pretty nice to substitute into things. And then we need to pick a point down this side of minus 3. So let's pick minus 4. So we're trying to figure out whether this function is going to be positive or negative in each of those regions. So we know that at these points it's going to be exactly equal to 0. But we want to know whether it's going to be positive over here or negative, and same thing in between them and over this side as well. So we're going to sub in each of these values. And we don't really care what the number is, what the actual value of y is. We only care about its sign, about whether it's positive or negative. But let's substitute in. So if we put minus 4 in here, we'd have y equals minus 4 minus 4, and then minus 4 plus 3 all squared. And if we figure that out, that would give us minus 8. So that's going to be negative. If we put 0 in there, we'd have y equals 0 minus 4, 0 plus 3, all squared. And that would give us minus 36. So that's negative as well. And if we sub x equals 5 in there, we'd have y equals 5 minus 4. 5. 5 plus 3 squared, and that would come out to give us 64, which is positive. So that tells us what's happening in each region. So below this intercept, our function is going to be negative, so it's going to be below the x-axis. Between our two intercepts, it's going to be below the axis as well because it's negative. But above this one, our function is going to be positive, so it's going to be above that axis. So our function is going to look something roughly like this. And that should be going through that point there, sorry. So that's a few examples of signs and intercepts.